this video, we're going to cover this concept called piecewise functions. A piecewise function is simply a graph of different pieces of different functions. We have three functions going on right here that we're going to graph. So the first one we're going to do is the one in blue. I want you guys to write to the right. H of x equals x over 3 if your x values are less than or equal to 0. Now this is the same as the graph y equals 1/3 of x. X divided by 3 and 1/3 of x mean the exact same thing. This is a linear function. What would be the slope of this function? And what would be the y-intercept? Aspen, what's the slope of this linear function? That's correct. Peyton, what's the y-intercept of this? 0 is correct. So what we're going to do to start this, now if you're working in pen, don't do everything that I'm about to do if you're working in pen. If you're working in pencil, you can do what I'm about to do. We're going to graph this function. We're going to start at 0, 0. We're going to put a point. And then we're going to go up 1 and over 3, and we're going to put another point. And then I can't go any further. So I can also go down 1 and over 3, put a point, down 1 and over 3, and put a point. However, I'm not allowed to graph all of these because I'm supposed to only graph if x is what? Less than or equal to a 0. Here, what's not my y value? What's my x value equal to way over here? A positive 3. So can I graph that if I'm only allowed to graph x is less than or equal to 0? No. So I'm going to erase that. What's my x value right there?
0.
0. So guess what? Am I allowed to plot that? Yes. What's my x value right there? Negative 3. So I can plot that. So listen, all I'm allowed to technically plot right now is this part of the line. You cannot graph anywhere beyond where x is greater than 0. You can plot everything less than or equal to 0. So that's the piece right here. That right there, that's the piece you're allowed to plot. Okay? And graph. So go ahead and get that done first. Then we'll move on to the next one. All right, the next one we're going to work on is in red. So right now I'm going to move over here to the right. I'm going to write h of x equals 2x minus 6. But I'm only going to be allowed to graph the x values that are between a 2 and a 0. All right, so I want you guys to write this function right here. What is the slope? If I said y equals 2x minus 3, what's the slope and the y-intercept of this function? All right, Fallon, what is the slope of this linear function?
2.
Wow, you really knew that one. Good job. All right. Cody, what is the y-intercept? Negative 6 is correct. So we're going to take this. Now, once again, if you're working in pen, don't do all of this. Right now, I'm going to graph the line, y equals 2x minus 6. I'm going to start at the y-intercept, 1, 2, 3, 4, 5, 6, down here at negative 6. I'm going to go up 2 and over 1. Why am I going up 2 and over 1? Because I am trying to plot the what of the graph? The slope. That's right, the slope of the graph. Now, don't do this. If you're doing this in pen, don't do this. Notice, right here, that line, try to go both directions. Yeah, 2 over 1, up 2 over 1. Now that would be the line y equals what? 2x minus 6. But where am I only allowed to plot? Where? Between what 2 points? 0 and 2. Unfortunately, this right here couldn't be plotted because that's at a 3. Tell me when my x value is a 2. Tell me when I get to a 2. Right there?
No.
That's at a 2.
Okay.
Right there. My x value is a 2. See right here? So my graph needs to stop right there. So don't do anything just yet. Right now, tell me when my x value is at 0. Not my y value, but my x value. Right there. So what I want you guys to understand, technically the only thing that's going to be plotted is between a 0 and a 2. So let me show you what you're going to do. Right here, now you can put this in, put an open circle because you're not including the 2. 2 over 1. Put another open circle because you're not including this value where x is a 2. You're including everything between the 2 points. So all the points between those can be plotted. Okay? That's why we have open circle here, open circle there. I'm going to slide over just a little bit so you can see this. This is the graph right here, 2x minus 6. There's the line. But what have I done? I've only plotted the x values that are between a 0 and a 2. All right, the final graph, everybody. The final graph we're going to graph is this one right here. So I'm going to do it right here below, so you guys don't have to move her around too much. But h of x equals 1 if x is greater than or equal to 2. And right underneath h of x, put y equals 1, because that's basically what our graph is. We're going to do a y equals 1 graph. Now this graph does have a slope, and it does have a y-intercept. All right? This is going to be a horizontal line. It's going to be a nice flat line, like all of us will be someday. Oh, wow. Right? Right? We'll all be flat lining it together someday. Maybe not together. Yes, how may I help you?
Do you have Exton Underwood?
I do. She is right here.
Can you send her to me? Ready to go.
Yes, I will. She will finish watching the lesson online. I felt like I was cut off there. All right. What is the slope of a horizontal line? 0 is right. Thank you, Vanessa. Now, what's the y-intercept? 1 is correct, Vanessa. I like it. So right now, what I want you guys to do is I want you to graph the line y equals 1, except don't do this. Don't graph the whole line y equals 1. Where are we only allowed to plot? Where?
When x is greater than 2.
Or equal to 2. So watch this. We're going to erase all of these points, because all these points are not greater than or equal to 2. Tell me when to stop. Okay.
Wait, that's on the line.
So there's the x value.
That's on the line.
By the way, this x is a 1, this x is a 2, this x is a 3, this x is a 4. We are only allowed to plot points where x is greater than or equal to 2. We're only allowed to plot the y values where the x values are greater than or equal to 2. That's what it's telling us.
So
This right here is your final answer as far as the graph. All right, the last thing we have to do is simply figure out the domain and the range. Now I realize we have 3 different graphs working at the same time. But the domain is the set of all of your x values. So what x values are being plotted? I'm going from negative infinity all the way over to 0. And 0 is being included. I'm going everywhere between a 0 and a 2. And then also 2 is being plotted and going everywhere to positive infinity. So technically the domain, everybody, is all real numbers. All right? However, in the range, not all real numbers are being plotted. Do you see a maximum height to this graph? How high does it get? To 1. Are all the values less than a 1? Or equal to? All the y values are either equal to a 1. Here they are what? They're going what? Less than a 1. Down here, what are they? They're all less than a 1. So all the y values are less than or equal to 1. And that's your range. Your domain is all real numbers, and your range, all the y values are less than or equal to a
so your range
1.
is like, what do they want?
Yeah, like what set of y values are being used? Only y values that are less than or equal to a 1 are technically being used. Okay?
Wait,
Now, less than or equal to 1.
So
Right now, what are all the y values here?
oh,
1. Are the y values here equal to a 1? No, they're all less than a 1. What are all the y values here? They're technically less than a, well, less than a 1. Right? All right, so turn your graphing calculators on, please. I want to hit y equals. I want you guys right now to type in 1 divided by 3x. Go down. Type in 2x minus 6. Go down. Change over here to change this to green. Okay? And here I'm going to type in y equals 1. Now, if we were to graph these three functions exactly as they appear, this is what your graph would look like if we didn't limit the domain. There's your first one. There's your second one. There's your third one. Those are all three functions that are graphed all at the same time, but what's different about this graph versus the graph that we did? They're going on what? Forever. Okay. Where did I get these numbers from? That's a good question. All right. These numbers right here, you can't see it. This number is a 1. I'm going to go back here. Do you see that one? That's x divided by 3. That's 1/3 of x. There's 2x minus 6. There's y equals 1. So I got all those numbers from, so this right here is 1/3 of x. Now, I'm going to show you now how to use your graphing calculator to only graph the portions of the graph that you need to plot. So hit y equals, clear this out, clear this out, clear this out.
Wait, mine's not. I graphed it though.
Hit alpha, y equals, enter. In the very first graph, after you do alpha, y equals, enter, do 1 divided by 3x. 1 divided by 3x. Then in the denominator, this is where you have to pay close attention. You have to hit second. Hold on a second. Hit the x value first. Sorry, hit the x value first. Hit second math. Go down to where it says less than or equal to. Number 6. And type in a 0. Once you do that, hit the graph button and take a look at your line. All right. Go down to number 2. y2. Hit alpha, y equals, enter. Type in 2x minus 6. 2x minus 6. All right? In the numerator. My apologies, I had to pause the video there for a second. I had to get people up. We're going to go down. Down. Just a tad. There we go. Thank you, sir. No, you will remain nameless. All right, Mr. Beard? All right. So, what we're going to do in the denominator is understand this one's a little bit trickier because we have an and statement. Hit the x. Second math.
Wait.
Number 5. 0. I heard somebody said what? If you go back, you realize we have x is what? Greater than 0, but less than a 2. So I got to go over here. Oh, I got messed up with the symbol there. It's got to be greater than 0. Bummer. Got to go back over here. My apologies. I'm going to hit delete. Second math. I'm going to hit greater, number 3. Type in a 0. Now, we have to actually write the word and in there. Here's how you do it. Here's how you put the word and. Second, math, right arrow, type in number 1 and hit and. X. Second, math, less than, just 5, a 2. And when I do that, when I hit graph, you will see, I'm going to hit zoom 6 so you can see all of it. There's our first one. There's our second one. And last but not least, we're going to hit y equals. Go down to the third slot. Hit alpha y equals. Enter. Type in a 1. Go down. Hit x. Second math is greater than or equal to 2. Then when you hit graph, you will see all 3 piecewise functions being graphed all at the same time. I'll go back here so you can see how they're all plotted. I'm going to take a screenshot. Class, there they all are. Put them in your journal so you know how to use your dadgum graphing calculator to help you solve these problems. Sound like a plan? I think so. Goodbye.